Hi, fifth graders. It is lesson 3.4 today. We are going to put some of our knowledge of similar triangles and similar figures to use and work through a problem where you can use um, similar figures to determine the length of missing sides in the real world. Now, I don't know if anybody will be doing any of this kind of measuring anytime soon, but it's possible. We'll start by going over the work from yesterday, the 3.3 lesson. In question A, you should have drawn a 10 by 20 rectangle for A1. For A2, you should have drawn a 2 by 4 rectangle. For A3, you would have drawn a 12 by 24 rectangle. So again, you are using the scale factors or the information to draw um, the rectangle that would meet the qualifications. For B1, you should have drawn this triangle here with a base of 28 and a height of 16. For B2, you would have had a height of 2 and a base of 3.5. In question C1, side AD is 4 because side AD goes with EH. You would have used the scale factor, finding the scale factor by doing 6.75 divided by 3. The scale factor was 2.25. Then, since you were finding the length in a smaller figure, you would have done 9 divided by 2.25, which was 4. You could have also done a different way. If you want to pause and read that section right here, you can. We did not talk about how to do that yet, so I'm guessing nobody did that, but you never know. C2, the scale factor from one figure to the other was 1.25 because 7.5 divided by 6. So DF is 3.75. FE was 6.25. Because the triangles are similar, the corresponding angle measures are the same. So F was 94 and B was 30. And that's where you needed to know that the sum of a triangle was 180. So the other two angles together, subtracted from 180, meant the last angle was 30. All right, in the lesson today, you are going to be finding links with similar triangles. Darrell, Angie, and Tanya are designing a triangular boardwalk that crosses a river for a class project. They make several measurements and sketch the diagram below. The students use similar triangles to find distances that are difficult to measure. The diagram shows a specific type of similar triangle called a nested triangle, which are triangles that share a common angle. So basically, a nested triangle is like a triangle inside of another triangle. I was going to use my pointer here to show you that you can see the big triangle here all the way to tree 1, to tree 2, to tree 3. That would be the big triangle. The interior triangle then would be from stake 1 to 3, right? 3 to 1 to 2 back to 3. So these are two right triangles. They share this angle in common. So obviously that angle is the same. They both have a right angle here. So if they have two angles that are similar or exactly the same in this case, the third angle right over here has to be the same because of the angle sum of a triangle has to be 180. If you have two angles that are the same, obviously the third one has to be the same as well because those are the three numbers that make 180. So the angles that look like right angles are right angles. They're telling you that. How are the angles in the smaller triangle related to the angles in the larger triangle? So that's exactly what I just said. Darrell claims he can use reptiles to show that the smaller right triangle is similar to the larger right triangle. Is he correct? So if we know that the angles are the same, the angles are congruent, all three angles are congruent, does that mean that these would be reptiles, that these would be similar triangles? So they give you one side here is 80, this side is 140. Could you use that information to find a scale factor? And then if you can use that, then you could use this short side here to figure out this long side there, right? So let's see what we find out in this next one. It says the two triangles are similar if corresponding angles are congruent. In a later unit, you will prove this fact. For now, we will assume it's true. So they're telling you what I just said, that yes, similar triangles, if you have all equal angles, corresponding angles are congruent, then the triangle is therefore similar. And like they said, you'll prove that later in a later unit. You'll probably prove that when you get to geometry in middle school. Problem 3.4 then. The triangles in the diagram on the previous page are similar. What is the distance across the river from stake 1 to tree 1? Explain your reasoning. So for that one, you're going to have to use the diagram on the other page. I did post a river diagrams PDF here if you want to look more carefully at it. It's also in your book, assuming you have a book. Um, Let's wait for it to load here so you can look at what we have. You could, this way you could draw on it if you wanted. Please don't draw on the books. So here's the first one. So what they want to know is the length just from tree 1 to stake 1. So you'd have to do a little math there to figure out the long side, but all they want to know is from the tree to the stake. Question B says, describe the relationship between the perimeter of the smaller triangle and the perimeter of the larger triangle. So again, once you find the scale factor, you should be able to figure that out. Question C, the diagram on the previous page shows 3 stakes and 2 trees. In what order do you think Durrell, Angie, and Tanya located the key points and measured the segments and angles? Explain your reasoning. So what do you think they did first? Stake 1, stake 2, stake 3, the measurements. How do you think they figured that out, and why do you think that? Question D says another group of students sketches a different diagram with similar triangles. They put their stakes in different places. Use the diagram below. So it's the same river, the same, is it the same river in the same distance? Yes, because the trees are 140 apart in both. So it's the same river, but they put their stakes a little closer together here, didn't they? Use the diagram below. Does the second group get the same measurement for the width of the river? So check and see, is the distance from stake 1 to the tree 1, is that the same in this diagram here? We know again that the triangles are going to be similar because they have corresponding angles congruent. Excuse me, your homework for today is questions 22, 25, 41, and 42. In 22, you're deciding who is correct. In 25, you are using a similar thing with the triangles. Here we're using the camper and the tent. That is a triangle there. And then all the way up is a triangle. 41 and 42 are also nested triangles. They just look a little bit different. Notice the diagrams are not to scale, so don't try measuring. You need to use the math and the scale factor in order to figure that out. All right, well, thanks for watching. Have a great day.